Imagine this. You are stranded. Your last bottle of clean water ran out 6 hours ago. Your throat is cracked and dry. In front of you, a stream, muddy, stagnant, alive with things you cannot see. Now imagine reaching into your pocket and pulling out two small strips of metal, one copper, one zinc. You twist them together, drop them into that filthy water, and walk away. 8 hours later, that water is cleaner than what comes out of most city faucets. No filter cartridge, no battery, no electricity, just two metals touching, doing what the earth designed them to do. This is not a survival hack someone invented on the internet last week. The ancient Egyptians used this principle 4,000 years ago to treat battlefield wounds. Greek sailors used it to survive months at sea. The Aztecs on the other side of the planet with zero contact with Europe discovered the exact same thing independently. And in the 1960s, when NASA needed to keep Apollo astronauts alive in space, their engineers looked at every cutting-edge technology available and built a device based on this same ancient chemistry. So here's the question worth asking. If two pieces of scrap metal can purify water this effectively, why does the global water filter industry generate $35 billion a year selling you plastic cartridges that expire every 60 days? That is what we are going to unpack today. Not conspiracy theories, just chemistry, history, and economics. And by the end of this video, you will know exactly how to build this system yourself. The year is 2400 BC, the banks of the Nile, the air is thick with dust and the smell of blood. An Egyptian field healer crouches beside an injured soldier. The wound is deep, a spear gash across the thigh. In this era, the wound itself is rarely what kills you. Infection is the real enemy. An infection begins with water. The healer reaches for a vessel, not clay, not wood, but hammered copper. He fills it with river water and sets it aside. He does not boil it. He does not add herbs. He waits. By morning, something has changed. The water is clearer. It carries a faint metallic crispness. The healer has seen this transformation hundreds of times. He does not know why it works. He only knows that soldiers whose wounds are bathed in copper, treated water survive, and those treated with plain river water often do not. This was not guesswork. The Smith Papyrus, one of the oldest surviving medical documents in human history, specifically describes copper as a sterilization tool for both drinking water and wound treatment. But Egypt was only the beginning. Around 400 BC, Hippocrates, the man we call the father of modern medicine, documented copper compounds as treatment for open wounds and lung disease. The Greeks took this further than anyone expected. Their sailors faced a terrifying problem. Water stored in wooden barrels turned green and rotten within days at sea. Crews died of dysentery, not from enemy ships, but from their own water supply. Yet water stored in copper vessels stayed drinkable for weeks, even months under the brutal Mediterranean sun. The Greeks had no concept of bacteria, no microscopes, no chemistry, but they observed a pattern that was impossible to ignore. Copper water meant survival. Wooden barrel water meant death. The Romans scaled this insight into infrastructure. Their engineers ran copper pipes through aqueduct systems, delivering noticeably safer water to public baths and homes. Roman legions carried copper vessels across Europe and North Africa, not as luxury items, but as standard military equipment. They understood, even without the science, that this metal prevented the waterborne diseases that historically killed more soldiers than swords ever did. Now here is where the story takes an extraordinary turn. Thousands of miles away across the Atlantic, the Aztec civilization had absolutely no contact with the Mediterranean world. Different continent, different language, different gods. Yet Aztec healers independently discovered the exact same phenomenon. They used copper-infused water as a gargle for throat infections and incorporated it into ceremonial purification rituals. In India, Ayurvedic tradition prescribes storing water in copper and brass vessels, a practice called tamrajal. This tradition is not ancient history. It is practiced today right now in millions of Indian households. 5 civilizations, 4 continents, thousands of years apart, all arriving at the same conclusion. This is not coincidence. This is chemistry. Fundamental, universal chemistry waiting patiently for humans to notice. For millennia, this knowledge was common. Copper vessels were standard in kitchens, hospitals, and ships around the world. Then came the Industrial Revolution. Copper was expensive. Plastic was cheap. Chemical chlorine could treat water at industrial scale. The old ways were abandoned, not because they failed, but because mass production demanded uniformity and low cost. Copper pots became plastic bottles. Natural purification became chemical processing, and an ancient understanding quietly slipped out of collective memory. It resurfaced by accident in 1984. A researcher named Don Heskett was running routine water treatment experiments. At some point during his work, he dipped a brass pen into a beaker of heavily chlorinated water. Brass, if you are not familiar, is an alloy of copper and zinc. What happened next stopped him cold. As the pen contacted the water, the chlorine simply vanished. No chemicals added, no electricity applied. The physical contact between the copper-zinc alloy and the chlorinated water triggered an instantaneous reaction that neutralized the chlorine completely. Heskett spent the next 3 years studying and refining this reaction. He patented the technology under the name KDF, kinetic degradation fluxion. But to understand why this discovery matters and why the water industry has kept it at arm's length, we need to look at what actually happens at the molecular level. Let me make this as clear as possible because the science is what separates this from internet folklore. When copper and zinc are placed together in water, they form something called a galvanic cell, named after the Italian scientist Luigi Galvani. Think of it as a tiny self-powered battery. Here is what happens step by step. The setup: zinc is a restless metal. At the atomic level, it desperately wants to give away its electrons. Copper is the opposite: stable, receptive, willing to accept what zinc offers. When these two metals physically touch while submerged in water, zinc atoms begin releasing electrons spontaneously. These electrons flow from the zinc into the copper. The water between them acts as the bridge that completes the circuit. The result is a tiny, persistent electrical current. You will never feel it. You could not power a flashlight with it, but at the molecular scale, it is a weapon. What this current does is 3 things simultaneously. 1, it eliminates chlorine. The electrical reaction forces electrons onto molecules of free chlorine, changing their chemical structure. Toxic chlorine becomes harmless chloride, the same compound found naturally in table salt. This happens in seconds, not hours. Let that sink in. Seconds. 2, it captures heavy metals: lead, mercury, arsenic, hexavalent chromium. These dissolved poisons are drawn into the electrical field generated by the galvanic reaction. Through a process called electroplating, they are pulled out of the water and permanently bonded to the metal surface. Trapped, locked in place. 3, it destroys bacteria. This is the mechanism that kept Egyptian soldiers alive and Greek sailors healthy. The galvanic current disrupts the internal enzyme processes that bacteria need to function and reproduce. On top of that, the reaction generates reactive oxygen species, essentially tiny molecular grenades that tear through bacterial cell walls. The water becomes a hostile environment where bacteria, algae, and fungi simply cannot survive. This is not magic. This is electrochemistry. It is the same principle that powers the battery in your phone. Except here, the battery is 2 metals, the circuit is dirty water, and the output is purification. If you are thinking this sounds too simple to be real, consider who else reached the same conclusion. NASA. In the 1960s, as engineers prepared for the Apollo moon missions, they faced an impossible constraint. How do you provide safe drinking water inside a tiny capsule floating through the vacuum of space? You cannot haul heavy filtration systems. You cannot waste energy boiling water. And you absolutely cannot use corrosive chlorine gas in a sealed, pressurized cabin where astronauts breathe recycled air. NASA's solution was an electrolytic silver-copper ion generator. It was the size of a cigarette pack. It weighed 9 oz. It required almost zero power. This device dispensed metallic ions directly into the water supply, successfully eliminating 100% of bacteria and preventing algae growth, all without leaving any chemical taste. When the Apollo technology was eventually declassified, it found commercial applications on Earth. Companies adapted the copper-silver ionization approach for cooling towers, public fountains, and aquatic habitats at marine research centers. The Environmental Protection Agency went further. It officially registered hundreds of copper alloys as antimicrobial materials capable of killing bacteria on contact. 4,000 years of human observation, peer-reviewed electrochemistry, NASA field testing, EPA verification. The evidence does not whisper, it shouts. So why is this not standard? Why does every outdoor store push $40 pump filters while a few dollars of metal from a hardware store can accomplish similar results? The answer is not a conspiracy, it is a business model. The global water purifier market is valued at over $35 billion per year. The profit engine of this industry is not the device. It is the replacement cartridge. Activated carbon filters saturate and expire every 2 to 6 months. You buy the pitcher once, you buy cartridges forever. It is in effect a subscription model built around a physical product. Now consider what copper-zinc technology represents to this model. A KDF-based filter removes chlorine, captures heavy metals, and inhibits bacterial growth. It requires no electricity and no chemical regeneration, and it can remain effective for up to 6 years. You cannot build a recurring revenue empire on a product that does not need replacing. This does not mean the industry has suppressed the technology. Copper-zinc media does appear in some commercial filters, but almost always as a minor supplementary component, never as the primary filtration stage. The emphasis remains on carbon cartridges that need regular replacement because that is where the profit margin lives. It is not villainy, it is economics, but the result for consumers is the same. The simplest, most durable option stays in the background, while the most profitable option takes center stage. Here is where this video pays for itself. Everything we have discussed, the history, the chemistry, the space program, means nothing if you cannot use it. But first, an honest disclaimer. Copper and zinc galvanic cells are highly effective against bacteria, chlorine, and dissolved heavy metals. They are not effective against everything. Specifically, they do not remove agricultural pesticides, and they cannot reliably eliminate parasitic cysts like Giardia or Cryptosporidium, which have hard shells that resist electrochemical attack. This is not a flaw, it is a boundary. Knowing the boundary is what separates a survivor from a victim. Now here is how to build a multi-stage system that covers those gaps. Stage 1, pre-filtration. If your water source is visibly murky, pour it through a cloth, a bandana, or a tightly woven t-shirt. This removes sediment, floating debris, and larger particles. It does not purify. It just prepares the water for the real work. Stage 2, the galvanic cell. Go to any hardware store. Buy a length of 14-gauge bare solid copper wire and a strip of pure zinc metal. Total cost under $5. Cut both to equal lengths about 12 in or 30 cm. Now twist them tightly together. This direct metal-to-metal contact is critical. Without it, there is no electron flow and no galvanic reaction. Drop the twisted pair into your water container, a canteen, a pot, a bottle, any non-reactive vessel. Wait. 4 hours is the minimum effective time. 8 hours is significantly better. Overnight, 16 hours is ideal. While you sleep, the galvanic current is silently working. Zinc atoms are releasing electrons. Chlorine molecules are being neutralized. Heavy metal ions are being pulled from solution and bonded to the metal surface. Bacterial cell walls are being destroyed. When you remove the metals in the morning, rinse them and store them dry. They are reusable for months. Stage 3, charcoal filtration. Take charcoal from your campfire, not briquettes, which contain chemical additives, but natural hardwood charcoal. Crush it into small pieces. Pack it into a clean container with a small drainage hole. A sock, a cut plastic bottle, or a piece of bamboo works. Pour your metal-treated water through this charcoal layer. The charcoal absorbs organic chemicals, pesticides, and residual tastes that the galvanic cell does not target. Stage 4, advanced diatomaceous earth. Diatomaceous earth is a soft white powder made from the fossilized remains of ancient microscopic algae called diatoms. Under magnification, each particle looks like a jagged, porous sponge. When water passes through a layer of diatomaceous earth, particles as small as 1 to 2 microns are physically trapped, including Giardia and Cryptosporidium cysts, which are too tough for chemical treatment, but too large to pass through this natural sieve. Diatomaceous earth is available at garden supply stores and costs very little. The result, by combining these four stages, cloth prefiltration, copper zinc galvanic purification, charcoal chemical absorption, and diatomaceous earth physical filtration, you have constructed a multi-stage water purification system from hardware store metal, campfire ash, and natural mineral powder. It addresses bacteria, chlorine, heavy metals, organic chemicals, pesticides, and parasites. It costs under $10 total. It requires no electricity, no batteries, and no replacement cartridges. And the core metals are reusable for months. 4,000 years ago, an Egyptian healer poured river water into a copper vessel and waited. In 1984, a researcher dipped a brass pen into chlorinated water and watched the chlorine vanish. In the 1960s, NASA engineers built a 9-Oz device using the same principle and sent it to the moon. The thread connecting these moments is not technology, it is attention. Someone in each era paid close enough attention to the natural world to notice what the Earth was already doing. Copper and zinc do not care about patents, subscriptions, or marketing budgets. They simply do what their atomic structure dictates. Release electrons, generate current, and make water hostile to contamination. The most advanced survival tool is not always the most complex one. Sometimes it is two metals twisted together in a canteen. The Earth already solved this problem. We just forgot to listen. If this exploration of ancient chemistry and modern survival has changed the way you look at the simple metals in your world, please subscribe and like the video. We are dedicated to uncovering the history and science that the modern world has tried to bury. Join our community of self-reliant thinkers. Let's plant the seeds for a more informed future together. The next hidden treasure of knowledge will be revealed very soon.